Hello everybody and welcome back. The next thing in the textbook is basic proportionality theorem. So before going into the details of this basic proportionality theorem, I have made one small demonstration of what this theorem is and how it works. So let me show you what I have constructed. Hopefully it should help you understand this theorem in a much better way. So here is a triangle ABC. You can see this triangle is a very flexible triangle. Now look at this point D on the green side, okay, and look at this point E which is on the red side. Okay, what I have done is I have drawn a line passing through point D and point E. Now this line is a special because this pink line is always parallel to this blue line. You can see it here, see, it's always parallel no matter what I do. Okay, it's always parallel. Now what this line does is it has divided the green side into two parts and it has divided the red side into two parts. For example, on the green side, because of this point D, now this segment AD is divided into segment AD and segment BD. At the same time, the red side is divided by point E into segment AE and segment CE. Look at the length. The length keeps on changing as I move the line. So length of AD is now 5.2 and length of BD is 3.5. Same on the other side. Now I'll show you the calculation of the ratio of the sides. Now look at this ratio, AD upon BD, and the value of this ratio is 1.5 and it keeps on changing. As I change point D, the ratio also will keep on changing. Now there is a similar ratio for the red side also, and you can see as I change the position of the line, which is always parallel to the blue line, the ratio changes, but you will notice that the outcome of the ratio for both the sides are same. This is what basic proportionality theorem is. You can see here, no matter what I do, as long as that pink line is parallel to that blue line, okay, the value of the ratio, okay, it is always same. Okay, this is the basic proportionality theorem statement. Now this statement is given in English language. The first thing I need to do is convert this into its geometry language. Now since the theorem is talking about a triangle, so I have taken 3 points A, B, C. Okay. Now I'm going to draw a triangle from it. So this is my triangle ABC. So let me fix one shape. Okay, I think this shape is okay. Now what I have did is I have marked a point D on line AB. Any point, it does not matter. Okay. And through this point D, now I'm going to draw a line which is going to be parallel to segment BC. Here it is. Now this line is parallel to segment BC. No matter where I move point D, this line is always parallel. See? Okay, always parallel. Now this line is intersecting the other side of the triangle at a point, and that point is point E. I got my segment DE. Also this line will divide segment AB into two parts, AD and BD, and it will divide segment AC again in two parts, which is AE and EC. Now I will write down what is given in the theorem. Okay, what is given? Segment DE is parallel to segment BC. Okay, and then of course point D divides AB and point E divides AC. Now the next thing is, what is the outcome. So this is the result of this theorem. The ratio of AD and the ratio of AE upon CE, they both will be same. So in other words, AD upon BD is equal to AE upon CE. So now of course the next step is we need to prove this theorem. Now the proof is already given in the textbook. What I'm going to do next is I'm going to just follow the same steps, but I'm going to go it slowly about it, and for each step I'm going to make some diagrams, okay, so that I can understand it much better, okay. And I'm going to try to put all this in this video, so that you also can follow along, and let me know if you find this explanation, the way I have done it, very clear or not. So let's go to the proof part. First thing, let me enlarge this triangle. And here is triangle ADE. Now I need to choose the base and I need to choose the height of this triangle. Here it is. In triangle ADE, AD is my base and EF is my height. So in triangle EF, so now area of triangle ADE, this is equal to, this will be is equal to half into AD into EF. Now I will mark this as result number 1. Now this is my second triangle, and you can see for the second triangle the height is the same. In triangle BED is again EF. So area of triangle is equal to half into, now this is my 2. Now I'll make a ratio. Now heights are same. Area of triangle ADED, this is equal to AD upon BD. This is an important finding, okay, between the two triangles. In the second step, I am again going to consider the same yellow triangle, which is triangle ADE. But this time my base is different, and so accordingly the height will also be different. Here it is, okay. Now the height is different, but the triangle is same. One more time, in triangle ADE, okay. This time our base has changed. Now it is AE, and height has also changed. It is BG. So accordingly, now area of triangle ADE is equal to half into AE multiplied by DG. This is 4. Now here is another triangle, triangle CDE, and you can see it will have the same height, which is DG. In the next step, in triangle CDE, now here my base will be CE and height will be same, which is DG. So accordingly now area of triangle multiplied by DG. So I'm having area of triangle which is equal to from 4 and 5 AE upon CE. Now this is my finding number 6. The next step is I'm going to take another two set of triangles. The first triangle I'm going to consider is BED. Here segment BE is parallel to segment BC. This is important. So here is the height for this triangle. In triangle BED. So area of triangle. Okay. Now I'm going to consider another triangle. Here is another triangle which is CDE, and you can see it has still the same base. The base is still the same, which is DE, and the height is EH in triangle CDE. Therefore, so area of triangle CDE will be, this is number 8. Now will be now look here closely. I have drawn both the triangles at the same time. Now important thing here is the heights are same and the base are also same. The two triangle area are also same. Whenever you have two triangles lying between two parallel lines, and if they have the same base, heights are automatically same. So the area of the two triangles will be same. Now I'm going to write the ratio of the two triangle area. How? Here it is. Now the base are same. You see, DE upon DE. They are same. And DI is equal to EH. This means S is equal to CDE. Now this is an important property. So we have got 9 findings. So what I am going to do next is to keep things simple and in one place. I am going to again write few important findings one after another so that it becomes very easy in one screen to look at the properties and whatever we have found out, compare and arrive at a result. So the first one is finding number 3. Here it is. This is the second important property. Here it is. And now I am going to copy the last important property. Here it is. So using 3 and 6, I can write on one side and again CDE on the other side. Now ADE are same, and we know that BED, triangle BED has got the same area as triangle CDE. Same area. So now that means, okay, I can easily write is equal to here. Okay, because the fraction value is not changing, it's the same. So now instead of writing the triangle ratio, I can straight away write AD upon BE. It is equal to AE upon CE. Now look at this final result that we have got. I'm going to copy it here. Now as you can see, this is exactly what we need to prove in the basic proportionality theorem. So that's a little bit detailed. I've tried to be as explanative as I can, so that anybody who is watching and who is trying to understand this proof of the basic proportionality theorem, they are able to understand it. Now with this, I complete my understanding of basic proportionality theorem. In my next video, I'm going to deal with the converse, the opposite of basic proportionality theorem. Till then, see you. Bye.